Hey, what's up? Welcome back to this new video. This one is paper 1-2 of May-June 2023. You heard right. This is the latest paper as of right now. It was sent to me by one of the students. But we don't have the marking schemes yet. But not a big deal. No worries. We will try to solve them together, step by step, as we go through this video. Without further ado, let's move on to the questions that we have today. Let's move on to question number 1. The equation of a curve is given to you by such that dy by dx is this. Right, so we don't have the equation, we have dy by dx for x is more than the value of 3. The curve passes through the point, so it has a passing point. Obviously, this is the x and y coordinates, respectively. Now, obviously, they give you something, we have to use it in the question. Now, the main topic is to find the equation of the curve. The equation of the curve is y. So, how can you find y from dy by dx? So we should know this. The concept behind this question is y is equal to integration of dy by dx. So that's the main thing we have to do to find y, which is the equation of the curve. So let's try. So y will be integration of dy by dx. Now I can rearrange this by the laws of indices. That should be 4. I can bring this up. That will become x minus 3 power minus 3. Right. Now 4 is only a multiple. I can leave this outside and the rest will be inside. So x minus 3 power minus 3 dx. Okay, now let's try to integrate this. So first thing first, of course, what do? We have to increase the power by 1. That should become x minus 3. Now minus 3 plus 1 will be minus 2. Now divide by the same power, and then divide by d by dx of the value inside, that will be just 1. Of course, plus c for your constant of integration. Now simplify, let's see what happens. That will be y is equal to, this will go away, that will become minus 2. That is x minus 3 power minus 2 plus c. Now, obviously, it's kind of hard to work with power minus 2. Let me send this below, right? That will become y is equal to minus 2 over x minus 3 squared plus c. Here you go. So now, it is not done yet. We have to find the value of c for this equation. Obviously, we have to use the passing point. That's why they give you this point. So we have to use this to find that c. Replace back in your equation. Y is 5 minus 2. That is 4 minus 3. That should be 1 squared, right? Plus c. C should be the value of 5 plus 2, and that will be 7. So finally, we have the equation of the curve, which is what? Y. Again, equation is y. Y will be minus 2 over the value of x minus 3 squared plus 7. And this is the equation of your curve for question number 1. Now let's move on to question number 2. The coefficient of x power 4 in the expansion of this is p. So that's the first thing we have to use, okay? And the coefficient of x power 2 of x squared in the expansion of this one is q. So that's the other thing we have to use. And finally, we also know that p plus q is equal to this whole thing right here. So we have a few things to use to find the values of a. So for the first one, the coefficient of x power 4. So we only care about the term which has x power 4 in this expansion. That will be x plus a power 6. So usually, how would you expand this? You will take the 6, right, the power, choose something. The first term is x, and then we have a. Now we need power 4, so I have to put 4 here. Makes sense, right? Now 6 minus 4 is 2. That should be 2 here, and this should match over here as 2. Great. So we only care about this term. That should be what? 6 choose 2 times, I guess the rest is just a power 2. So that'll be 15 a squared and then x power 4. Now the question tells you the coefficient of this one, which is the value in front of this, which is this. So we have 15 a squared is equal to the value of q. of p, sorry. That's the first equation. So we have this for part 1. Now, similarly, let's proceed for the next part of the question. The coefficient of this, in this expansion now, so we have ax plus 3 power 4. Usually you would expand this how? You would take 4, combination something, the first term is ax, and then here we have 3, plus 3, right? Now we need x power 2, this have to be 2 here, right? 4, it to be x power 2. Now 4 minus 2 is 2, 2 will be here, and this have to match over here. Now simplify, let's see what happens. That should be 6. 3 power 2 is 9, and that should be a square and x square. Now 6 times 9, that should be what? That should be 54, so 54 a square x square. Now again, one more time here, we only care about the coefficient. The coefficient is the value in front, which is right here. So that'll be 54 a square is equal to the value of q according to your question. And finally, we also have this to use to find the value of a. So pretty easy. P plus q. So P plus q is supposed to be 276 according to your question. So replace, that should be 15 a square, 54 a square, that should become 276. 15 plus this, that should be 69. Let's check. Always check, because why not? 15 plus 54, that should be 69. Indeed. 276 divided by 69, that should be 4. So a square is a value of 4. Therefore, the possible values of a, that should be plus minus square root of 4, that should become plus minus 2. There you go. And this is your question number 2. Now let's move on to question number 3. We have to express this whole thing right here in the form of this. So we have to complete the squares where a and b are integers, which are whole numbers, and c is to be given in terms of p. Alright, now you can of course proceed using your formula to convert that to this form. However, the easiest way that I find is solving by comparison, right? So what I can do, I can expand this. That should be x squared plus 2 bx plus b squared plus c. Expand, you will have a x squared plus 2 abx plus ab squared plus c. Now I can solve this by comparison. That should become 4 x squared minus 24x plus b is supposed to be in this form. Now by comparison, I can have this should be this, which is a has to be 4 by equating coefficients. Next one here we have this is supposed to be this, which is 2ab supposed to be minus 24. Therefore 2 times a, b minus 24, b should be the value of minus 24 divided by 8. That will be what? Minus 3. Let's double check, because why not? Here you go. So we have a and b. Alright, cool. And then what else? We have to find the value of c. So ab squared, we have what? A is a value of 4, b squared is minus 3 square, plus c is supposed to give you the value of p. 4 times 9 plus c, that should be p. Therefore c will be p minus 36. There you go. C will be in terms of p, right? Now finally, we have to place them back in this form, because that's the whole idea, right? We have to do this. A is a value of 4. That will be x. B is minus 3. Square plus c is p minus 36. And this is your answer for question part A. Part 3a. Now for part B, hence or otherwise, so we can use that or otherwise, we have to find the set of values of p, for which this equation, which is the same equation right here, has no real roots. So whenever you see no real roots, we always think of what? The discriminant have to be less than 0. Now, just to be consistent, we can just use our normal method that we use all the time. Take the same equation here, which is 4x squared minus 24x plus p. This is the value of a. I guess according to the quadratic equation that we use usually, that will be b and c. Again, we're not continuing this, we're just trying to use the usual method that we use. So a is a value of 4 here, b is a value of minus 24, and c is a value of p. Again, it is just according to our equation that we use for the quadratic formula, right? Now finally, when we say no real roots, we really mean discriminant have to be less than 0. So discriminant is b squared minus 4ac have to be less than 0. Now b squared is this value over here, minus 24 square minus 4 times a times c less than 0. That will be 24 square, that will be 576 minus 16 p less than 0. Divide by 16, that should be 36 minus p less than 0. So that'll be, this have to be less than p. Again, you can rewrite this in other ways if you want to, but it's the same thing. So that will be your set of values for p, for which it has no real roots. Again, you can write this the other way, p is more or whatever. It doesn't, it's the same thing, right? You get the idea. Now this is the question number 3. Now let's move on to question number 4. So here we have to solve this equation. Okay, it's only for 3 marks, by the way, so that will be an indication that it should not be that hard. But of course, we may panic because we are not used to solving a question where x has power of 6. So what can we do? We can use substitution. For example, you might say, well, let u equal to x power 3. Right, now your life will be way easier if you think about this. I can rewrite this equation as 8x power 3 square, right? Makes sense, right? Plus 215 x power 3 minus 27, and that should be 0. That will be 8 u square plus 215 u minus 27, 0. So now you can see it is a very simple quadratic equation, right? Now, how do you solve this? Usually you can use your formula as well, or you can just use factorization. It's up to you, right? It's your preference. That'll be 8u times u for 8u squared. 27 could be 27 times 1. Now, 8 times 27 is a value of 216. To get 215, have to minus 1. Therefore, that should be plus 216 minus 1 to get this one. Finally, 8u minus 1 is equal to 0, so u will be the value of 1 over 8. u plus 27 is 0, so u is a value of minus 27. But of course, we don't care about the value of u here, we want to find the values of x. So replace back in here. X cubed is 1 over 8, therefore x will be cubic root of 1 over 8. That will be half. Same thing over here, so x cubed is a value of minus 27. X will be cubic root of minus 27. That will be minus 3. So these are the two values that we have for a solution for your equation right here, for question number 4. Only for 3 marks. Now let's move on to question number 5. The diagram shows the curve y equal to this. So here we have a curve with this equation. The curve meets the x-axis at these points, so we have these 2 points already given to you. Perfect. So we have to find the area of the region. So how do you find area below curve? We use integration, right? You should know by now. So here you go, area. Integration, limits will be 4 and 0. And the equation will be 10 x power 2 minus 5 over 2 x 3 over 2 dx, obviously. Let's see what happens. So again, one by one, you can take your time with this. There's no need to rush. Now, okay, to make your life easy, let me break it down into 2 parts. The first one is integration of 4, 0. I can leave 10 outside. It's only a multiple, x power half. Then minus 5 over 2 outside, integration of 4, 0, x 3 over 2 dx. For this first part here, 10 is standard outside. So here we have x, we have to increase by 1, that should become 3 over 2. Then divide by 3 over 2 become 3 here and 2 here. And then we have the limits of 4, 0. Right, 10 is 10. Now become 4 here, so let's do this. So 4 power 3 over 2. So here we have this value times 2 divided by 3. That will become 5 1 over 3. Then minus, if you replace 0, that will become 0. Makes sense, right? Let's try one more time. That will become 8. So 2 over 3 times 8. Indeed, this value over here minus. When you place 0 here, that will become 0. Doesn't really matter. Okay, cool. That's the first one. Multiply. Times 10. That will become 53. 1 over 3. So for this first thing, it will become 53 1 over 3. Now how about this one right here? Similarly, 5 over 2. Here we have minus sign. So let's leave this for now. 5 over 2 is outside. Integrate. That will become x increased by 1. That should become 5 over 2. Right? If you check, 3 over 2 plus 1. That will become 5 over 2. Then divide by the power, 5 over 2, 5 here, over 2 becomes 2 over here. And then we have the limits of 4 and 0 again. So 4 power 5 over 2. That will become 32. Times 2 over 5. That will become 12 something. So 5 over 2 here. That will become 12. 4 over 5 minus, if you place 0 here, that will become 0 all thing. Again, you can do this all together if you want to, because it's not that hard. Or you can break it down to 2 pieces and then take your time, slowly try to, integrate and then plug them back in. Now this time this times 5 over 2, that will become 32. So finally, we have to, of course, take the first one minus the other one. So here you go, and here you go. That'll be 53 minus answer. That should become 21. 1 over 3 units square for the area, or otherwise I can expand this. 21 times 3 plus 1, that will become 64 over 3 units square as well. Okay, that will be area below the curve for this question. Okay, this is your question number 5. Now let's move on to question number 6. The diagram shows a sector OAB, O, A and B, okay, of a circle center O, and the angle here is theta, and then here we have X and X. Alright, now question 1, you have to show the arc length AB, so this thing right here is equal to this. So first thing first, we should know by now, arc length is equal to the radius times the angle. The radius we don't know. The angle we know it is theta. So we have to find the missing value, which is the radius, which is OA or OB. Now how can we find this? There's a few ways. It's up to you to choose your preferred method. Now for me, I can see here we have an isosceles triangle, X, X. And then what I can do here is, if I were to kind of play with this, if I were to draw a vertical line from P down to this line over here, this have to be 90. Again, how do I know this is 90 and these two are the same? Is because these two are the same, and if you were to draw a vertical line, you will have to be cutting line OA into exactly 2 pieces at right angle. Okay, cool. Now, I can take out the triangle over here. So you will have O, this one, this and P. Fair enough. Here you go. This is P, this is O. Let me call this one T. This is 90, this is theta, and this is X. Now, I want to find this length, the length of OT. How would I find this? By using SOHCAHTOA, obviously. This is the A side, this is the hypotenuse, so we have to use which one? Let's check. SOHCAHTOA. So here we have the A side, A and A, and here we have the hypotenuse, H and H. Here we have these two. That should be cos. Cos of the angle theta is equal to A side, which is OT, over the value of H, which is the hypotenuse. Therefore, OT is equal to X cos theta. Now this one is X cos theta, but this is also X cos theta. So finally, I can conclude that from here, OA is equal to 2x cos theta, right? Because it's the same thing, times 2. Now finally, we can find the arc length AB by using your formula, which is radius, which is 2x, cos theta, which is the length, this one or this one, right? And times the angle theta, which is right here. So here you go. Now this is equal to 2x theta cos theta, shown as required for the length of arc AB. 2 marks. Now for part B, we have to find the area of the shaded region APB in terms of x and theta. Now again, it is up to you what method you want to use, but the logic behind is the same. How would you find the area right here? You will first find the area of the whole thing minus the area of the triangle over here, right? So how would you find the area of the whole thing? This is the area of a sector, right? Which is half r square theta, right? So the area of the whole thing will be half radius square, which is this one, 2x cos theta square, and then times the angle, which is just theta, right? R square is the radius square, and then theta is just right here. Now replace and simplify and see what happens. That will become half is half, that will become 4 over here, x square cos square theta times theta. This will go away. So you will have 2x square theta cos square theta. This is the area of the sector. Now I need to remove the area of the triangle, this one. Right? How would you do this? Now again, we have done this so many times by now, we will have to use our formula to find this, which is what? Half times this side and this side. So this side is x, and this side is what? It is the value of 2, the radius 2x cos theta, and times sine of the angle in between, which is sine of theta. Here you go. This and this will go away. You will have x squared cos theta and sine theta. Okay, and this is the area of the triangle over here. This is one of the method. Of course, you can use other ways. We can use half times base times height. You have to find the height. It's up to you, but you should get something like that, right? So finally, the area of the shaded region have to be the whole thing, which is 2x squared theta cos square theta minus the area of the triangle. That will be what? We can factorize if you want to. Here we have x squared common, and here we have also what? The value of cos theta common. That will become 2 theta cos theta remaining minus the value of sine theta. So this could be your answer for the area. You can write, here we don't have any units. You can write units square for the area of this region. Again, the logic is the same behind finding the area of the whole thing, sector, minus area of triangle to find this one. And this is your question number 6. Now let's move on to question number 7. by first expanding this whole thing right here. We have to find the three solutions of this equation for this domain. So let's first expand this. So that will become cos square theta plus 2 sine theta cos theta, right? And then we have plus sine square theta. Now simplify. We have cos square plus sine square, that it will be the value of 1. So we have 2 sine theta cos theta plus 1. So this whole thing will become this. Now if you want to simplify further, you can also simplify this, but there's no need, it's up to you. So replace it back in here. This whole thing became this, so you have 2 sine theta cos theta plus 1 is equal to 1. Simplify, you will have 2 sine theta cos theta is equal to, send this over here, that will become 0. Now solve. Now the thing is, this is factorized already for you, so we can just solve one by one. So first thing, we have 2 sine of theta is 0, and cos of theta, that will be 0 for the other solution. Now if you want to, what is this thing? This is what we should know. Sine 2 theta is equal to 2 sine theta and cos theta. So you can always change this to this as well. It's up to you. You can do that if you want to. Now we can solve this one by one. For the first one, sine theta is equal to 0 using the quadrants. ASTC, you have to be here for the angle, or here, which is the value of pi minus theta. So that will be what? Theta is a value of sine inverse of 0. That will be 0. That's the first value. But also, we have to look at this quadrant. That will be pi minus 0. That should be just pi. So here we have 0 and pi as your answer for this one. Now let's move on to the other one. Here we have cos theta 0. So one more time, looking at the quadrants. ASTC, so that should be here. And cos should be here. This is the angle directly. And this is 360, which is 2 pi minus the angle. So here we have theta. That should become cos inverse of 0. That will be pi by 2, right? Let's double check. Cos inverse of 0. We can use degrees to check. That should be 90 degrees, which is pi by 2. So it is this value, but also this one, which is 2 pi minus pi by 2. That should be what? The value of 3 pi over 2. But that will be too much because according to your question, we only care about the values in the first two quadrants. So this will be too much. So finally, the solutions will be theta is equal to 0, pi by 2, and then pi. That is part A of your question. Now for part B, hence, we can use that information, right? Verify that the only solutions of the equation this, cos theta plus sine theta equal to 1, between this domain are these two. Now at first we do realize, at first we had the equation of cos theta plus sine theta square is equal to 1. And for those, the solution were 0, pi by 2, and pi. Now from this, we have to kind of check, verify that for this equation, without the square thing, it has to be only these two. So how can you kind of play with that, or kind of use this to your knowledge? Now again, we understand that if you were to remove this, cos theta plus sine theta was actually solving this equation, plus minus 1, right? So in this case, we understand that when you have these three values here, you were supposed to get 1 or minus 1. But in this case, we only care about the plus 1 part. So let me actually just make it simple. Let's go directly with what we have. So considering the only positive side, considering this one, cos theta plus sine theta equal to 1. Let's check. Let's use the values. When theta is equal to 0, that will be cos of 0 plus sine of 0. That is equal to 1, which is indeed 1. Cool, which is valid. When theta is equal to pi by 2, that will be cos of pi by 2 plus sine of pi by 2, that will be actually 1, which is equal to 1. Good to go. Let's check actually. Sine of pi by 2 radians, that will be 1 indeed. And cos of pi by 2, that will be 0. Now finally we can check for this one when theta is equal to the value of pi. That will be cos of pi plus sine of pi. Let's see what happens. That will be minus 1, which is not equal to 1. So in this case, the only two valid solutions derived from that equation initially, right? So we understand that theta would only be the value of 0 and half pi for this equation. For this equation. For this one. And this is your question part B. Actually part A part 2. This is part B now. So we have to prove the left hand side becomes the right hand side. So how can you prove this? Well, obviously we always try to do this step by step and use the principle for fractions. So since the base are different, we try to make them become the same by doing cross multiply and then multiply them by each other. So I hope you know this from till now, right? Because we have been doing this since O level, so hopefully you know how to simplify fractions. So first thing first, cross multiply. Sine this time this, you will have sine theta cos theta minus sine square theta. Now plus this thing times this, so 1 times this will become cos theta plus sine theta minus this time this will become minus cos square theta minus sine theta cos theta. And of course this whole thing will have to be over the value of these times this. Now by observation you can see, what is that? Again, you will learn this by experience. This is cos theta, sine theta, but here we have plus minus. That will become the difference of squares, if that makes sense. Because we should know by now, for example, you have a plus b times a minus b. What does that give you? That will give you a squared minus b squared, right? Therefore, I can just use the same concept. That will give me cos square theta minus sine square theta. That is my base. Now simplify the whole thing. On top, these two will cancel out. Here you go. And then we have this one. That will be cos of theta plus sine of theta. Here I have this and this. I can factorize that outside. For example, if I take a minus outside, that will become sine square theta plus cos square theta. Right? Makes sense, right? If you factorize the minus outside, you will have this. Now this whole thing, divide by what? Now this is this. I have to make this become in terms of sign. I can change that. That will be 1 minus sine square theta minus sine square theta. Right? This is derived from this. Now simplify. That will be cos theta plus sine theta minus 1. Right? Now divide by 1 minus 2 sine square theta. Shown as required for 3 marks. Done. Now for part C now, it's a long question for sure. We have to use the results from A2, which is solving the equation, and then part B, this one right here. We have to solve this equation. So this whole thing right here is equal to this. For this equation. Let's try and see what happens. Now we understand that from part B, this whole thing became this. So just plug this back in here to solve. So let me continue here for more space. So right now I have what? I have cos theta plus sine theta minus 1. Over the value over here, it is 1 minus 2 sine square theta is equal to, this one is 2. Now I will not expand this. That will become 2 cos theta plus sine theta minus 1. Now to make my life easy, let me call this whole thing here x. So this is the same as this, so this will be x as well. I can just cross multiply first to simplify this whole thing. You will have x is equal to, again, you can call this whatever you want to, or you can not call this, you can not use this method. You can always go by the long method, take your time one by one. But I don't like to rewrite the whole thing over and over again. I just want to call this x for my own sake. Now x here is equal to 2x times this. That will be 1 minus 2 sine square theta. Here you go. Now simplify. Now I can send this over here, right? You will have 2x 1 minus 2 sine square theta minus x is equal to 0. Now let me continue below. I can factorize the x outside. You will have x here. That will become the value of 2 here remaining. Expand, that should become 2 minus 4 sine square theta minus 1. Because we have factorized the x already outside, it will be minus 1. That is 0. Now, that will be x. That will become 2 minus 1 is the value of 1 minus 4 sine square theta is equal to 0. Now, this is factorized for you already, so we can solve directly. The first equation we have will be x is equal to 0. And then 1 minus 4 sine square theta is equal to 0. Okay, now obviously we're not solving for x. We know x is equal to what? Cos theta plus sine theta minus 1 is 0. Therefore, I have seen this before, right? From equation or question, part A2. This question right here. So, it is the same domain, as you can see from question A. This one, same domain, all these two values, 0 and pi by 2. So for this equation, you will have theta, 0 and half pi. How about this one? We have to solve. That will become 4 sine square theta is equal to 1. Therefore, sine square theta is equal to 1 over 4. Therefore, sine square theta will be plus minus half. Right. So again, there will be two possible values here. Sine theta is equal to half, or sine theta is minus half. Now remember, the domain that we care about is only this 0 to pi, which is the first and second quadrant, right? This one is positive. We understand when sine is positive, it will have to be here and here. This is your angle directly, and that should be pi minus theta. So theta will be the value of sine inverse of half. That will be the value of 30, which is what? Let's double check. Sine inverse of half, that will be 30, which is pi by 6. It could also be the value of this one, pi minus pi by 6. It could be 5 pi by 6. So here for this equation, the two possible values could be pi by 6 or 5 pi by 6. This or this. Now, for this one, if you understand, when sine is negative, it will be in which quadrants? It will be ASTC. You have to be here and here. This is the third and the fourth quadrant. Now, because it doesn't lie in the first two quadrants, there's no need to find these because it will not give you answers that satisfy our conditions. In this case, we can ignore this one. So we only have 1, 2, 3, 4 possible values of theta for this domain, for this equation. And this is your question number 7. So let's move on to question number 8. So what we have here, the diagram shows the curve, the graph y equal to f of x, where the function f is defined by this equation right here. 3 plus 2 sine 1 over 4x for the values of x between this and this. Okay. Now part 1 is we have to sketch the graph of y equal to f inverse of x. Now how would you usually sketch the graph of y equal to f inverse of x? Now you're being tested upon the to find the relationship between f of x and f inverse of x. So you guys should know by now that it is basically a reflection across the line y equal to x. So we have to kind of use that line as a guide to help us sketch the other graph. So let me first draw a line over here to help me. That should be something like that. Here you go. Again, this is not the answer. It is just a line, y equal to x. It will just help me to sketch the graph of f inverse. Now, I'll try to measure this. Again, it is only a sketch. It doesn't have to be exact. Use a pencil. You can always erase if it's wrong and then restart again. So let me count this over here. Seems to be what? 5, 6, 7. 5, 6, 7, around this part right here. Okay, and it should pass over here. And then this one, let's count. There's 1.5678, 1.5678 on this line over here. Okay. Look, it is not exact, but that's okay. It's only a sketch. Now try your best to join them by a smooth curve, which is same as this, but on this side. It should be something like this. Okay, and here you go. Not perfect, but you get the idea. It should be reflection across the line y equal to x. Of course, label this one y equal to f inverse of x as your answer for question part 1, part A. Now for part B, we have to find an expression for f inverse of x. So how do we do this? So step number 1, we always do what? We let y equal to f of x. F of x is 3 plus 2 sine of 1 over 4x. Now the goal here is to make x become subject, right? So send this over here, y minus 3. Then divide by 2, that will become sine 1 over 4x. Now I can try to make 1 over 4x become subject. That will become sine inverse of the other value, which is y minus 3 over 2. Finally, x will be 4 sine inverse of y minus 3 over 2. So done. Now basically we have to write the equation for f inverse of x. So f inverse of x, it is in terms of x, right? We have to change the y to x. Here you go, sine inverse. That will be x minus 3 over 2. And this is part B of your question. Now let's move on to part C of your question. So the diagram shows part of the graph g of x is equal to 3 plus 2 sine 1 over 4x. It's the same thing, right? As previously. So we just call this now g of x. Now we have to complete the sketch. Again, sketch doesn't have to be exact, of the graph of g of x on the diagram above, and hence explain whether the function g has an inverse or not. So let's first try to complete the sketch. So one thing we know about sine curve is what? It is cyclic. Usually, if you have a sine curve, it looks something like this, right? It is cyclic. Right? Cyclic. Everything that happens over here happens the same way over here. Okay? Now, one thing we can do, I would say usually in exams, if you don't want to think too much, we can just use a table of values, right? That will be x and y. Now x, we have the values here already, so we have to find the one over here from 0 to minus 2 pi. 0 is done. That should be minus pi over 2. And then we have minus pi, minus 3 pi over 2, and minus 2 pi. And find the corresponding values of y, so we can complete this sketch. So this is one of the ways you can do that, or you can just use common sense logic by looking at the equation directly. For example, let me try this first, and then we can try the other way as well to show you guys. First value is what? We have pi, so minus pi, over 2 as the value of x. Now here we have sine, so over 1 over 4 divided by 4. Sine of your answer times 2 plus 3. So the first value here will be 2.23. Next value will be minus pi times 1 over 4, right? Sine of your value times 2 plus 3. That'll become 1.59. Next one is minus 3 pi over 2 divided by 4 sine of your value times 2 plus 3. That'll be 1.15. And the last one is minus 2 pi. So minus 2 pi divided by 4 sine of your answer times 2 plus 3. That'll become 1. As you can see, as we go in this direction, the value will decrease, right? It will be decreasing until the value of 1 over here. Now, of course, you can plot the points. You can do that as well. But I think I'll go with the other way, which I think is easier, in my opinion, because it's only a sketch. It doesn't have to be exact, right? So, by looking at this, I can see that, well, the y-intercept, this is the intercept, is 3. So basically, the value here has to be 3. Okay, cool. Now what else? I understand that the amplitude is 2. So basically, the max point here has to be 5. Okay, now this is the max point. We understand you will also have a minimum point over here. This is 2 pi max minus 2 pi. We have to be going in this direction to a minimum point as well. Now let me count to use a scale on the graph as we have over here. Let me count this. So I can see that this distance is what? It is 5, 10, 11, 12, 13, 14, 15, 16. So here we have 5, 10, 15, 16. Somewhere over here. So basically at the value of minus 2 pi, you should touch that point. Okay, so now again, you can always go ahead and plot these points and join them with the smooth curve. Otherwise, just find the maximum point and the minimum value over here. Try to join them with a smooth curve to show that you understand the shape of the curve. Let me use a different color here. I'll use purple. So basically, yeah, just try your best to kind of continue the trend. Of course, use a pencil. There you go. Have to be a smooth continuation. And this is your question, part C. Now for question here, explain if it is inverse or not, has an inverse or not. The answer is yes, because we have seen this before in, I think in AdMath, we use the horizontal line test. For example, if you were to draw a horizontal line here, 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 or here, it will have only one value, one point of intersection. Because of that, it is called a one-to-one function, and hence we confirm it has an inverse. So here you go. By using the horizontal line test, we can confirm that g of x is a one-to-one function, and because of that, hence we confirm g of x has an inverse. That's the reason why we can safely say this is true. That is part C of your question. Let's move on to part D of your question. We have to describe fully a sequence of 3 transformations which can be combined to transform the graph of y equal to sine of x for this domain from 0 to half pi to the graph of y equal to f of x. So basically, at first, we begin with y equal to sine of x. How did we change that into f of x is y equal to 3 plus 2 sine of 1 over 4x. There's a few things that happen here, but it's very evident. You can see that here we have this thing, right? And here we don't have it. It's just 1. And you may also notice that here we have this, and here we don't have anything And also in the back here we have something. We don't have anything here, but here we have something over here. So we have 3 transformations that happen to change this into this. So the sequence here, we can always begin with the values here, which is, I think, which is the not the simplest, but we can begin with that. So the first one, number 1. So how did we change sine x to 1 over 4x? Sine 1 over 4x. What does that mean? So we had to, is that a stretch or a squash? Because you can see the graph has extended. Usually the graph looks like this, kind of squeezed, but here we have it's kind of stretched. So you will say it is a stretch horizontally along the x-axis, right, by a scale factor of, this is 1 over 4. There you go. That's number 1. Now number 2, we have this thing here. Here we have nothing. So from here to here, that will be what? That will also be a stretch vertically along the y-axis by scale factor of 2. And the last thing will be this one. What is that? It is a movement up. So we can write it is a translation vertically upwards or vertically along. Again, it is already along the y-axis, but we can write this as well, no problem. By, so here we have 3 by 3 units. There you go. So here we have the 3 transformation that is combined together to change this into this. And that is your question number 8. Now let's move on to question number 9. The second term of a geometric distribution is 16 and the sum to infinity is 100. So first thing first, we do know already it is a geometric distribution. So once we know this, let's write down the formula we know for that kind of distribution, progression. So let's write this. So we should know the nth term is equal to a Rn minus 1. For the sum to infinity, that should be a over the value of 1 minus r. So by using that now, we can place the values in the equations and form something that we can use. The second term, when the n is 2, the value is 16. So that will be 16 over here. That will be a, we don't know, r we don't know. 2 minus 1 is 1. So this is my first equation. I need to find the 2 possible values of the first term is a. So let me make r become subject. R will become 16 over a. That is my equation number 1. Now over here, sum to infinity was given to you by what? By 100. Okay, so we just replace, that will become 100 is equal to a over the value of 1 minus r. Now we can just cross multiply. That will become 100 minus 100r is equal to a. Now replace, r is this, that should become 100. This times this, that should become 1600 over a. Now, I don't like to work with a as the base. Let me multiply by a everywhere. So I can remove this, right? That will become 100a minus 1600 is equal to a square. Send everything to one side, you will have a square minus this plus 1600 equal to 0. Now you can of course try to factorize using the brackets, or you don't want to have any headaches. We'll just use the formula directly. A has to be minus b, which is 100, plus minus root of b squared minus 4 times a times c. That will become 3600 over 2a, which is the value of 2. So a can be 2 values. The first one is 100 plus root of answer divided by 2, that could be 80, or it could be 100 minus root of 3600 divided by 2, that could be 20. So we have two possible values for A. Okay, so the question is asked you is we have to find the two possible values of A. So A could be the value of 20 or 80. That's the first two values. This is your answer for question part A. Now obviously I can always go one step further. I can try to find the value of R already. When A is equal to the value of 20, R will be the value of 16 over A. 16 over 20. That will be the value of 4 over 5. Cool. When A is a value of 80, R will be 16 over 80. That should be 1 over 5. So here we have these two derived from those values already. Now for part B, we have to show that the nth term of one of the two possible geometric progressions, it is equal to this one. We use this multiplied by the nth term of the other one. So let's first find the nth term of each of them, and then we can decide, right? So for the first one, we have A is 20 and R is equal to 4 over 5. Now the nth term we should know. The nth term, the formula is what? It is ARN minus 1. So that should be for the first progression. That should be the nth term. A is 20, R is 4 over 5, power n minus 1. That's my first progression. Similarly, the other one is A is equal to 80, R is a value of 1 over 5. Therefore, for my second progression, I understand that should be n term, that will be 80. That will be 1 over 5 n minus 1. Now the question is telling you that we have to show that if you take one of them and multiply by this, you get the other one. Now which one is it? Do we take this one times this or this one times this? But you know, the truth is, I don't know. What would I do in exams? I will try. I will just try and see what happens. So you have two options. You can take this one. Let me call this the first one and second one. You can take Tn1 times 4n minus 2 and solve and see what happens. Or you can take Tn2 times 4n minus 2 and then solve and see what happens. But logically, we can kind of observe here, right? Oh, again, we should not know. Let's just say we don't know. So we have to try. Let's see what happens. Now, my instinct, let me go with this one. Why not? That will be 80. That will be 1 over 5. I'll use this one, minus 1 and minus 1 times this one. That will be 4 and minus 2. Now, this is just indices. We have to know how to play with that, play around and then change that into what we need. For example, I can see here it is 4 over 5. We have 5 already, but we need to change that into 4 and then power n minus 1. Now let me kind of break this down, right? That will be what? First thing first, I can play with that. That will be 80 here. That will be 1 power n minus 1 over 5 power n minus 1 times, that will be 4 power n minus 1 times 4 power minus 1. If that makes sense, right? I can just take 1 off and I can write this in terms of this. That makes sense? Yeah, hopefully that makes sense in terms of we use indices. Otherwise, let me make it easier for you guys. Let me not think about this. I have 80. That'll be, now 1 power anything is just 1. So 1 over 5 and minus 1. Now this one I can write 4 power n times 4 power minus 2. Fair enough? Fair enough. Now simplify, that will become 80. Now 1 over 5 n minus 1, 4 power n. Now I can bring this down. You agree? That should become 4 power 2. Now remember, I need to change this into this. I need to have 20 over here. So I have 80 here. How do you make 80 become 20? Divide by 4. So basically I try to divide by 4 here. That'll become 4 power 1. and that will become 20. So now this thing is done. I have 20 here already as required. I forget about this. And then here I have 1 over 5 n minus 1. And then here I have 4 power n over 4 power 1. Now can I simplify this? Yes, of course I can. That should become 20. And that will become 1 over 5 minus 1 times 4 and minus 1. Now because the powers are the same, they can be combined together. That should become 20 times 4 over 5 and minus 1. So basically I was able to prove that if I take the second geometric progression multiplied by 4 and minus 2, I get the first geometric progression. Again, initially I don't know, you can try for both if you want to, but eventually you will have to use the second one times this to get this. Right. And that will be question number 9. Then let's move on to question number 10. The equation of a circle is given to you by this right here. Okay. Now we should know this, right? We should know that if the equation is given to you as such, we can derive the center of your circle. So usually the center have to be the value of a and 3. Okay, and this is the supposed to be, because here we're supposed to have r square, and this is the radius, so therefore anyways we don't need this right away, but for now I understand that by looking at this, I have the center of my circle. Now we also have a line equal to y equal to half x plus 6. It is a tangent to the circle. Now this is a key word here, tangent to the circle at the point P. Of course you can draw something as an illustration. Again, it is not accurate, it is just something to help you understand what's happening, right? Let's say we have my circle over here. This is the center of my circle, right? And then let's pretend I have a tangent over here passing through this point. This is y equal to half x plus 6. This is the point in question. Now, usually, what does it really mean? If my line is a tangent to the circle, it just means that the tangent and the line and the circle only meet at exactly one point. They have only one solution, they have only one point of intersection. And what does it translate to? It translates to, usually we call this the discriminant have to be equal to 0. That's what it means. Therefore, let's try to solve this, and then we can use that concept to find the values of a. So let's do this. Here we have the equation of my circle. Let me replace his back in here. Let me expand this first. You will have what? You will have x squared minus 2ax plus a squared. Here we have what? So y minus 3. Y is this value. Minus 3 should become half of x plus 6 minus 3 should be plus 3. If that makes sense, right? Expand, you will have the value of 1 over 4 x squared plus 3x plus 9. E is equal to 20. Now simplify. Here we have 1 plus 1/4, that should become 1.25 x squared. And then here we have plus 3 minus 2a, factorize the x outside, here you go. And then finally you will have plus a squared plus 9 minus 20, that will be 0. Now simplify, that will be 1.25 x squared plus 3 minus 2a x, and here what do I have? Plus a squared minus 11 is 0. So now if you look at this properly, we have what? We have a quadratic equation. Makes sense, right? By observation. Now we have to use that concept. Now we've talked about the discriminant have to be 0 because there's only one solution. Therefore I can say that b squared minus 4ac have to be 0. B squared, this is b squared, that should become what? 3 minus 2a squared minus 4 times a, which is 1.25, which is the value over here, and c is the value in the back. and all this have to equate to the value of 0. So let's play around, let's expand and see what happens. This will become 9. 2 times this, that should be 6 times 2 minus 12a plus 4a squared. 4 times 1.5 is minus 5. Let's check, why not? 4 times 1.5, that should be 5, right? Times a squared minus 11 is 0. Simplify. That will become 9 minus 12a plus 4a squared. That will become minus 5a squared plus 55, and that will be 0. Simplify again. 4a squared minus 5 should be minus a squared minus 12a. We have 9 plus 55, that should become plus 64. Send everything to one side because I want to make this become positive. That you have a squared plus 12, a minus 64, that will be the value of 0. Now you can solve this by factorization, or you can solve this by using the formula if you want to. Now let me try to factorize myself. Let's see what happens. So a squared is a times a. 64, I should know what are the factors. Divide by 6, but not possible. Divide by 4, that is 16. So let me try this. 64 is 4 times 6, so 4 times 16, sorry. Now to get the value of plus 12, I have to have plus 16 and minus 4. Now solve, obviously this is good to go. So value of a can be 4, or the value of a could be minus 16. So the question asks you, show that one possible value of a is 4, and find the other one. So we have shown that one of the possible value is indeed 4, and the other one is minus 16. And this is your answer for question 10 part A. Now let's move on to question part B. So now we are moving on with a value of a equal to 4 now. We have to find the equation of the normal to the circle. Okay, so let's try this. Now before we even begin, usually, I think we have learned this in O-level. Let's say I have a tangent, right, to my circle. If I were to join the point of intersection, this point, right, to my radius. For example, I understand this have to be 90 over here. We have done this in O-level, right? We should know this. Now, we're trying to find what? Find the equation of the normal to the circle at P. This is the point P right here. Now, we don't have the point P, however, since we're trying to find the equation of this blue line, if that makes sense, right? We have a passing point, which is the center of my circle, which is a is 4, 4, 3. Should be pretty simple. So for part B, the passing point that we have derived, it will be 4, 3, which is the center of my circle. Now what is the gradient? To find the equation of a straight line, we need the gradient. So what is the gradient of the line, of the normal? So we should know this is the tangent perpendicular to my tangent. We have the normal. Since they are perpendicular, I understand that the gradient have to be minus 2. Makes sense, right? Because we should know the gradient of tangent multiplied by the gradient of normal has to be minus 1. Since this one is half times this, get minus 1, this will have to be minus 2. Now how do I know it's half? Because you can see here the equation of your tangent is this. Now y equal to half x plus 6. By comparison, y equal to mx plus c. You can see here we have the gradient, and this is the gradient of your tangent by comparison. So now we have these two, we can just use our formulas here to find the equation of that line. That's the x and y value. So y minus 3 over x minus 4 is equal to my gradient. That will become y minus 3 minus 2x plus 8. Y equal to minus 2x plus 11. And this is your answer for question part B. Now let's move on to part C of your question. For the same value of a, we are using the same value now. Okay, we have to find the equations of the two tangents to the circle which are in the same direction as the normal found in part B. Okay, so basically we have this. We understand that the tangents have to be in the same direction as this. Therefore, by observation or using your logic, common sense, where should the tangents be? If they have to be in the same direction, it could be here, or it could be here, right? So we have two tangents to find, this one or this one, same direction. Now because they are in the same direction, we understand that the gradient of those lines are also -2. That's one thing we know right away. Now something else, of course, to find the equation of lines, we have to know the passing point. So what is the point over here, and what is the point over here? So how can you find those points? I believe there's a few ways, at least two ways I can see. However, I think the easiest one for myself will be what? I can use this one. I can simply try to find the equation of the line passing, right? Passing through those 2 points. Has to be in the same direction as this, right? Therefore, the gradient of this line has to be the value of half, but the passing point will be the center, which is what? The passing point 4 and 3. So let me use that. So let me first find the equation of this line. Let's see what happens. So the passing point I have is 4 and 3, and the gradient of that line, from what I can see, is half. Now y minus 3 over x minus 4 is equal to half. That should become 2y minus 6 is equal to x minus 4. Therefore 2y is equal to x plus 2. This is the equation of this line. Now to find these 2 points, this one and this one, they are the point of intersection between this line and the circle. But we also have the equation of the circle, so we can use it directly, right? Circle was given to you by x minus 4 square plus y minus 3 square is equal to 20. I can replace this here, make x become subject, send this over here, that will become 2y minus 2, replace here, 2y minus 2 minus 4 should become 2y minus 6 plus y minus 3 square is 20. Now simplify and see what happens. That will become 4y square minus 24y plus 36 plus y square minus 6y plus 9. Now simplify this and this, that will become what? 5y square. Then we have this and this, that will become minus 30y. And finally we have 36 plus 9 minus 20. That will become plus 25. Divide by 5 everywhere to simplify this whole thing, right? Y square minus the value of this plus 5. Now we have a quadratic equation that we can try to simplify. We can factorize. That will be y times y. 5 is 5 times 1. To get minus 6, we have to have minus 5 minus 6. Minus 1, sorry. So y equal to 5 and y equal to the value of 1. Now let's find the corresponding values of x using this equation right here. So x has to be 2y minus 2. So when y was 5, x is the value of 2 times 5 is 10 minus 2 is 8. When y was the value of 1, x will be the value of 0. So the points that we have over here, in here, we found this. The first point that I found was 0, 1, this one. And then we have 8, 5. So we have these 2 points that we can use to find the equation of this tangent and this tangent. So for the first one, again, they have the same gradient because they're in the same direction as the normal, right? So we understand that the gradient here have to be minus 2 for both. Therefore, y minus 1 over x minus 0 has to be the value of minus 2. That's for the first one. So that cross multiply, you will have minus 2x over here. So y is equal to minus 2x plus 1. That's the first one. Continue. For this one now, y minus 5 over x minus 8 is a value of minus 2. Y minus 5 is minus 2x plus 16. That'll be y is equal to minus 2x plus 21. So we have these two are the two equations that we have for those tangents that we are talking about here, which is in the same direction as this one, but as tangents. And this is your question number 10. Now let's move on to question number 11. This is the last question in this paper. Let's see what we have. The equation of a curve is given to you by this, okay, where k is a positive value. Now we have to find dy by dx. So we have to differentiate. So first thing first, let me rewrite this. We have y equal to k. Now square root is simply power half, right? We should know this by now. Here we have minus x plus 5. Now using this equation, now we can find dy by dx pretty easily. So dy by dx, k is only a multiple, leave this outside. First multiply by the power, then we have 4x plus 1, then power minus 1, so half minus 1 is minus half. Then times d by dx of this, that will become 4. Minus, that will become 1 plus 0. Right here we have minus x will become minus 1. Simplify. This will go away. This will become 2 over here. So you have 2k. We can bring this down, become square root of 4x plus 1 and minus 1. This is your value of dy by dx in terms of k. Done for part A of your question. Now for part B, we have to find the x coordinate of the stationary point. So we have to use it as a hint to do what? To know that at stationary point, what do we know? Dy by dx have to be 0. So you use this as a hint. Okay, so let's equate that to 0. Again, I'm continuing this here because I have more space. So let me use a space. So I equate that to 0 to find the stationary point. I send this over here. You will have 2k over the value of root 4x plus 1 equal to 1. Now we can cross multiply. That will become 2k. That will be root of 4x plus 1. Square both sides, that will become 4k squared is equal to 4x plus 1. Simplify. We have to make x become subject, right? Here we have to find the x coordinate. That will become 4x is equal to 4k squared minus 1. So finally, divided by 4x will become k squared minus 1 over 4. And this is your answer for question part 2. Now let's move on to part C. Given that the value of k is 10.5. Okay, so that is a good thing. We know this now. So at first, from question part A, we had the equation of the curve is y is equal to what? K is 10.5 root of 4x plus 1 minus x plus 5. Also, we derived the value of dy by dx was found to be 2k, 2 times k, let's see. 2 times 10.5, that will be 21. 21 over the value of root 4x plus 1 and then minus 1. This is your dy by dx derived from part A. So let's see what can we do here, or what can we use to find the answer. So we have to find the equation of the normal. That's the main goal of the curve at the point. So we don't know the point where the tangent to the curve makes an angle of this one. So the angle, let's call this theta, is equal to tan inverse of 2 with the positive x-axis. Okay, now again, we can draw something. Again, it is only used as illustration. Don't take my word for the shape of the graph because I don't even know the shape. I'm just using this as illustration, right? So this is, let's call this the x-axis for example. There you go. This is the x-axis. Now let's pretend, again, I'm saying pretend, the shape of the graph is something like this. Okay, cool. Now, at the point, we don't know the point. Let's pretend the point is somewhere over here. Right? Here we have a tangent. Let me continue this line here so we can have a clear view of what's happening. Tangent is a straight line passing through this point. Here you go. This is my tangent. Where the curve makes an angle, tangent makes an angle of this one. The angle is theta here. You'll make an angle of theta over here, for example, right? Now, what does that really mean? Again, we have to derive the meaning from this. This is the tangent to my curve, but the most important thing, the angle here will be theta. Now, I understand I'm given that theta is equal to tan inverse of 2. Now, I can say, well, tan theta is 2. Now, 2 is 2 over 1. Makes sense, right? Now, usually, if you go to draw a right angle triangle, what is that really? Let's say this is 90 over here, this is theta. Tan is what? Opposite side over a side, that will be 1 and 2. Which means this is a slope of the tangent, if that makes sense. Because at any point here, I can draw the triangle, and then it will be in the ratio of 1 to 2. Therefore, I understand the slope will be the value of 2. Hence, from this, I can derive that it just means the gradient of tangent is a value of 2. So let's use this. Now, since we know the value is 2, but we also understand something is that what is the gradient of tangent? It's simply dy by dx at that point. That is 21 over root of 4x plus 1 minus 1 is equal to the value of 2. Again, at this point that we don't know, right? That's what's happening. Now, we can play around, send this over here, you will have 21 over root of 4x plus 1 is equal to 3. Cross multiply, you will have 21 is 3 root of 4x plus 1. Divide by 3 on both sides, you will have 7 over here. That will be root of 4x plus 1. Now, square both sides to remove the square root. That will become 49. And that will be 4x plus 1. Send this over here, become 48. That will become 4x. X will be the value of 12. And also we can find the y value as well. Y value, use the equation of the curve. This one. That will become 10.5. Square root of 4x plus 1, 4 times x plus 1. That will be 49 minus x minus 12 plus 5. So 10.5 root of 49 minus 12 plus 5. That will become 66.5. Again, the whole thing amounts to what? I did all this thing for what? Because I wanted to find this point. So the point here in question was the value of 12 and 66.5. It is important to have a passing point to find the equation of a line. That's why I had to find the point. Now, the goal is to find the equation of the normal. Normal is a perpendicular line to the tangent. So we should know by now the relationship between tangent and its normal, right? So since we know the gradient of tangent is a value of 2, we can derive that the gradient of normal is a value of minus 1 over 2. That's something we should know. Now we have a passing point, we have the gradient, we can find the equation of the normal pretty easily. X and y value. So y minus 66.5 over x minus 12 is equal to my gradient. Let me find the equation now, cross multiply and see what happens. That will become 2y minus what? 2 times 66.5. That will become 133 is equal to minus x plus 12. So finally, 2y is equal to minus x. We have 12 plus 133. That should become plus 145. Of course, you can make y become subject if you want to. Now, there's no need. So finally, the equation of the normal is y minus half x plus 145 over 2. Or you can leave this as such as well for your answer for the equation of the normal. And this is your question number 11.